Hi everyone, this is Tas, and today I'm going to be talking about the application of machine learning to international business. Um, this video is for anyone who's interested in data science, machine learning, data analytics, economics, international business, and business in general. So in this case, I'm taking an international corporation, which is Starbucks, and I'm asking one simple question. Can machine learning models determine and classify and predict whether a country is a good market for Starbucks? As a country that doesn't have Starbucks, I used Ukraine because I have background. I grew up in Ukraine, and Ukraine is very interesting case in terms of coffee consumption. The market is growing, and I was curious whether why Starbucks is not present there, and so taking machine learning course, I decided to give it a shot, and so I used in this project 6 machine learning models, and they all gave their own answer. So stay tuned for the results. And additionally, if you're interested in Python code, in the data set, it's on the GitHub. I'll provide the link below, so don't worry. And at the end of the video, I'm going to be going over code and explaining how it works. You can see on the world map, some countries have Starbucks, some of them don't. And so in the data set that I gathered, it's consisted of 159 countries. 72 of them do have Starbucks. So what's going on here is pretty much machine learning models are giving data to be trained and analyzed and see patterns. And so a little bit of the background. I'm assuming everyone knows Starbucks. It's an international company. It's present in 72 countries, and the data set that I gathered consisted of 158 countries. And so half of them, half of the countries in the data set do have Starbucks, half of them don't. And so as you can see on the map, majority of the stores is in the United States, of course, but it's a global company. It's been around the world over 30 years. It is international expansion. It started from Canada, and now it's almost in every country in the world, almost. But then in this project, again, not too serious. I mean, I have limited data, but I'm asking, machine learning models to kind of learn and see the patterns in the data using some features and trying to predict whether Ukraine is or any other country. This is actually replicable and can be used for any company, just given data and not just Ukraine. So why Ukraine? Long story short, I'm from Ukraine, and so I've been visiting Ukraine pretty often over the past 70 years, and so the coffee consumption culture and the coffee culture in general has exploded over the past less than a decade, and imports and the consumption has increased almost 2.5 times since 2014. And so there are a lot of indicators saying and indicating that Ukraine's consumption and coffee is exploding. The number of coffee shops, the number of businesses opening, the number of people, young people consuming coffee is increasing drastically. But it's still yet a very young relatively market compared to United States, South Korea, or high coffee consumption countries like Belgium, Netherlands, Scandinavian countries, etc. So there is definitely a case for Starbucks. And so what I'm asking here is, given the data, what are the results? How would machine learning models classify Ukraine, where Starbucks is not present yet? For future, if you're able to construct and add a column on the feature of currency stability, so exchange rate stability with the US dollar for all these countries, that would be awesome. I mean, I didn't have time and I couldn't do that. As well as the average national income. However, that is pretty much very highly correlated with the GDP per capita, simply because GDP per capita is an economic indicator that showcases and illustrates the national standard of living. I'm using coffee consumption per capita data population, ease of doing business index, and FDI. FDI in foreign direct investment, and it's simply here because it's an indicator of how much foreign investors are confident in investing in the country. These are the following models, six models and six algorithms that I'm using. Again, I'm going to be going over, in depth about them in the code later in the video. And if you're interested in knowing in depth how these work, you're welcome to Google and learn. And I recommend StatQuest and Towards Data Science. .com, videos on YouTube. There are a lot of people who explain this better than me. But these are the models that I'm going to be using: naive Bayes classifier, decision tree, random forest, k-nearest neighbor, support, vector machine, and logistic regression. I use so many just out of curiosity. But my initial plan was to include naive Bayes, decision tree, and random forest. And so, especially decision tree and random forest, they are more, interpretable for business. And the way the work is, decision tree is pretty much taking the most important features and putting them on top. And so for every data point, for every country in this case, there's a specific value above or below that, guides us through the decision tree at every node. And the leaves of the tree here are the output and, pretty much the classifications. And so I already have a decision tree on the slide later, specifically for this project, for this Starbucks case. And so random forest is just like a decision tree, with the exception of it's a lot of trees, and each of them randomizes the the combination of these columns, of these features of the variables, and we're taking the average or the majority vote of these trees. And so these are the results of this project. Again, some of these models are more accurate than the others and more relevant. But I was curious to what extent others are going to be classifying Ukraine as a Starbucks market. And so decision tree, random forest, KNN, and logistic regression classify Ukraine as a Starbucks market. And so these are the results of the project. Again, some of these models are more accurate than the others, but the majority of them classify Ukraine as a yes. And so again, if we are, considering and assuming that accuracy score of 80 and above is good enough and below is not that good, then, according to decision tree and random forest, Ukraine should be classified as a Starbucks market. I had to do cross-validation score. These are the average accuracy scores for each model. I used k-fold method, and so it's we split the data set 7 times, and we're randomizing the learning or the training of the model based on different parts of the data set. And so these are the average accuracy scores. Feature importance. Why is this important? Again, it pretty much, according to decision tree and random forest, this is the ranking of the variables, which are more important than the others. So it turns out FDI is the most important one for classifying a country. What is interesting here is that coffee consumption turned out to be not that important for classification of a country at all. This is important for later part of the video. This is the decision tree that was constructed by Python. I prettified it and I changed it a little bit so it can be readable for someone who is not a data scientist. But pretty much, again, FDI was turned out to be the most important feature. And so this is how it works. FDI of Ukraine is around $5.5 billion invested in the country. Of foreign direct investment. And so what is the node asking here is if the FDI is less or equal to 3.3 billion dollars. And so in our case, it's not, it's greater. And so we're going here to this node, and this node is asking, is the population less or equal to 9.4 million? It's not. Population of Ukraine is around 40 million people, and so again false, and we are trapped in the leaf of which classifies Ukraine as a yes, as a Starbucks mark. If Ukraine had a population smaller than 9 million, and then again smaller than 8 million, 8.8, that would be not the case, and Ukraine would not be classified as a country, as a Starbucks country. Again, just want to point out here that there's no correlation, and Starbucks is in, has more than 4,000 locations in China, and they're on average not consuming coffee at all. It's more about the middle class. And whereas there's an interesting case with Australia that Starbucks failed to expand to Australia because it has an already established coffee culture there by Greek and Italian immigrants. Same thing with Italy. But yes, this is an interesting thing to talk about. Again, the conclusion is back to the machine learning models that we don't know, and if we're trusting the accuracy of of random forest and decision tree, again, the data set is only 150 data points, rows, and so it's not that big of a data set, and it's has a higher error. But it was interesting to actually apply this to international business. So this is the code portion of the video. I'm going over this Python script to explain what's happening so you can replicate that. I will make sure to post code on GitHub with the data set so you can go and play with it. But pretty much what's happening is that I'm importing this CSV file. So, I mean, even though this is open in Excel, this is a CSV file. And what I'm doing here is that I'm importing it and I'm setting up, I'm importing as a pandas data frame, and I'm setting up the target column, the target variable for training of the models right away. And so our target column is the Starbucks presence, which is our Y. It's binary 0, no, is the Starbucks present or no, so two classes. And I'm doing that, and I'm dropping other variables. So some of them I didn't have to have, and I use them for statistical analysis and everything. But I'm dropping whatever is unnecessary, so I'm having only those that I need. And then what I'm doing is that I'm splitting the data set. So I'm taking this 159 countries, and I'm splitting 80% of this going to be a training data. So I'm providing the models with the patterns with these data, and I'm matching the X, so these X variables with the Y target variable for training. So machine learning models, they can learn and see patterns and in their own unique algorithmic mathematical ways. And then 20% is going to be the test size. So the 20% of the data set is going to be, this is how much data the models are going to be tested on for accuracy. Okay, and so then I jump right to the models. I'm importing an base from sklearn. This sklearn package is the major one that I'm using here, obviously for machine learning purposes. I'm constructing the model. I'm training with xtrain, xy. So again, this is xy for training, and this is xy for x variables for testing, but not all of them, only 80%. And then I'm saying predict me all those other 20% for testing, and I'm going to output them right here. And then the most important part, I'm asking, and I'm asking to predict with the Ukraine's specific set of X values, I'm asking to predict whether or not it's a Starbucks. So is it a belongs to a class 1 or 0? So the machine learning models, they don't know whether Ukraine is a market. And so given the data, so in this case, 1.79 kilograms of coffee consumption a year. This is GDP per capita. Then goes the population. Then goes the ease of doing business score, and then goes the FDI. So given this, what the naive-Bayes model is going to how it's going to be classify Ukraine, and this is I'm doing pretty much the same thing with all 6 models. And the only difference in the code is that for decision tree, I'm asking to export and draw the actual tree, and I'm going to show it in a second. And at the end, I'm just asking from decision tree and the random forest model the ranking of features. This is pretty much it. And let's see. I'm going to show it in a second. So yes, so pretty much this is how it's outputting. So the first one is for this line, for example, for naive-Bayes, I'm asking is Ukraine a Starbucks market, and it pretty much gives me the class that it thinks it belongs to, which is 0, which is not, and it's 95% confident in that. But the overall model's accuracy score is the cross-validation score. It's 76.5%. Then I'm ranking the feature importance, so it looks pretty much the same thing as I showed in the slides. And this is how the decision tree, actually, I apologize, looks like, but I had to change it. It actually gives the Gini score, so the long story short, it's a probability metric for each feature. So X1, X4, and its ranking, and it's pretty much the same that I showcased in the slide. So this is the video. Thank you so much for your view, for watching, and I'll make sure to provide the code. And thank you so much.